the part E. Have you think of the answer? If you look at the graph, what can you say about the speed of the lion as time passes? As time passes, what happened to the speed of the lion? The speed of the lion is, yeah, decreasing over time. Right? So if I name this T1, but the speed of the zebra is increasing over time, am I right? So from T equal to 0 to T1, whereby they have the same speed, okay? The speed of lion is greater than the speed of zebra. So which means lion will be closer to zebra. Am I right? But after that, after T1, the speed of the lion speed is less than the zebra. Am I right? So which means the zebra will move further away from the lion. So therefore, when they are at the same speed, that is a time whereby the lion is closest to the zebra. Get me? That is how you explain. So find the time at which V1 equal to V2. So you can use either algebraically, they didn't say exact time, so I can use my GC to get the answer. You find the intersection point, so you get your T is 5.6 second. So, understand? So, we also must learn how to solve it algebraically, correct? Do you know how to solve it algebraically? So, you put V1 equal to V2. So, V1 is 15e to the power negative 0.1 t is equal to 20 minus 20e to the power negative 0.1 t. Am I right? So do you know how to solve this? Do you know how to solve this?
Yeah.
Yeah, you know how to solve this, correct? So here got 15 of them. You bring the 20 of this here. So in total, you have 25 of them. Am I right? 35. 35, am I right? Negative 0.1 t equal to 20. Correct? So you can divide by 5 for both sides. So I got 7 over e to the power 0.1t is equal to 4. So my e to the power 0.1t will be equal to 7 over 4. So my 0.1t will be equal to ln 7 over 4. So t will be ln 7 over 4 divided by 0.1. So it will be 10 ln 7 over 4. So you must know how to do this in a algebraic way as well. So that's why I purposely show you. So it will be this value. Now, can I move on? Okay. So I'm going to move on to part G. So the question asks, did the lion catch the zebra? So what is very important is in this question, correct, you have to read the first line. What is the distance between the lion and the zebra when first the lion noticed the zebra? When t equal to 0, the lion is here. And the zebra is here. Right? And their distance away is 40 meters. Okay, this is the situation at the beginning. Sorry, this is the beginning situation when t equal to 0. Okay, this is the beginning. Okay, whoever is it, you text me. You all keep texting me like that, I go crazy. Okay, you get me? Those who come in late, have you logged into that one? This is the idea, please. Quick, 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 quick. So let's come back to here. When it's T1, correct, that is 5.6 seconds. So you have to find the total distance traveled by the lion. Then you find the total distance traveled by the zebra from 0 to 5.6 seconds. Okay. Hello? You get me? So before you go to situation at t equal to 5.6 seconds, what you need to do? You need to find total distance traveled by lion. So that means you have to do the integral from 0 to 5.6. What do you put now? Y1 dt. Okay. So can you use your calculator and tell me the answer? Then you count total distance traveled by the zebra. Okay, 64.3 meter. Okay. The distance traveled by zebra. integrate 0 to 5.6 y 2 dt. Okay, 26.2. Okay, I'm going to use green to represent zebra and blue to represent the lion. Okay, so now lion is here. So now I mark down the position first. Here is 40 meters. So lion start from here. It travel 64.3 meters. Okay, can or not? So zebra is here. Okay, and it travel until here is 26. I just delete off this one first. Here to here is 26. Okay. This is the starting point for lion. So now, so that means for zebra, if you count the distance, zebra as reference to this point, it will be 40 plus 26.2. That is 66.2. But for the lion, it is 64.3. So does the lion catch up with the zebra? Okay. Did the lion catch the zebra? The answer is 2.0 meter ahead. The zebra is 2.0 meter ahead of the lion. So the lion did not catch up the zebra. Can or not? So this particular beginning, the distance is very important. So read the first part of the question carefully. So the answer is no. So if not, how close did the lion get to the zebra? So the lion, the closest it can go will be 2 meters behind the zebra. Okay or not? Okay, so this is one of the application of integration. Okay. Another application of integration will be the one that you can see in the exercise 5D. So always remember, if I have the graph of dy over dx. Okay. So you see, I do everything on top. So the total amount of y from x equal to a to x equal to b is equal to integrate dy over dx graph from a to b. So this is the meaning of area bounded by the curve. Are you clear? Okay or not? Okay, so now if you look at exercise 5D, So there are a lot of terms that you have to learn. Like velocity is the rate of change of displacement. Okay. If you look at exercise 5D, and if you look at example 10, what is the meaning of question 1? Marginal cost. What is the meaning of marginal cost? It means rate of change of cost. So you have to know marginal cost is rate of change of cost. So that's why they give you C is the cost. So they give you C prime T. So this is the marginal cost. Are you clear? So next time, they will not tell you that C prime T is marginal cost. They will just tell you marginal cost is this and this. So you know that is C prime T. And what is C? C is the cost. So the unit is dollar per gadget. Okay, and this one we have to be very careful because the gadget is what? Whole number. So find the total daily production cost. So if I want to find the daily production cost, so that means I want to find the cost function. So what should I do? What should I do? If I want the cost function, yeah, I should integrate the C prime T. So I will get back my CT, correct? Okay. So now you are supposed to integrate this. The book give you is 3.15 plus 0.004 T dt. Okay. You all should know how to differentiate. Am I right? Can you please differentiate that? Integrate. Sorry, you see, I also speak wrongly. Integrate that. Okay, can you tell me if I integrate a number, what will I get? If I integrate a number, what will I get? Gerald, are you there? Can you just speak to me? If I integrate a constant, what will I get? Give it a try.
Zero.
Zero? Cannot. That is differentiate.
Hey, my bad. You add another.
You like this, Harry?
Who is talking to you? Huh? Gerald? Why got that noise there? That's why you dare not on your mic. Who is that?
My brother.
Your brother? How come your brother is with you? Huh?
I am at home, miss.
You are at home, I know. You have your room, correct? You should be in your room.
Okay,
You
now
cannot... Yeah. Okay? Yes. 3.15 what? Please, you are doing integration. Don't get mixed up. Yes. Someone have told me, you integrate a constant, you just write down the constant times T. correct? So if you integrate this, you copy down the whole thing. Power plus 1 divide by the power plus C. Hello? You all are not doing your homework. Some of you are, I don't refer to everyone, okay? Okay, so now I have to find a way to get this C. So you go back to the question, you say, find the total daily production cost for 800 gadgets given that the fixed cost before production commences. So what do you mean by the fixed cost? Before the production commences means the number of items that is your T is 0. So what is the cost? The cost is 450. So now you put the cost as 450 and you put the T as 0. It's better to substitute in. So what is the C? In this case, it's 450. So therefore, now we have the cost function. That is 3.15t plus 0.002t squared plus 450. Done. Anything with marginal means rate of change of that thing. Can or not? Same go with question 2. So I will leave it that for you to do. Can or not? Hello?
Yes, Miss.
Okay, good. So same go with the rest. Okay. Okay, let's try with question 7. Okay, question 7, you talk about the water flow into the boat and out of the boat. Can you please go to question 7? Under page 146. Okay, every time when you have the 2 different functions, it's good to key into the calculator and start to do. Okay. Can I give you 10 minutes to do that, to read through the thing? Okay, usually I will write down properly. Okay, so they want the rate for part A, you should be able to do, correct? Can someone sketch the graph for both and send it to me? So that we can, is the amount of water in the kayak increasing or decreasing after 2 minutes? Okay. So I have to do part A first. Okay, part A is 1.65 liter per minute. Okay, R2T is 6 minus 6e to the power. Oh, I wrote it wrongly. This one should be 0.1, huh? Negative 0.1 T. Negative 0.2. So this one, the answer will be 1.09. Okay, based on this, so that means 1 minute, you can, the water flow in is 1.65 liter, but you only scoop out, build out 1.09. So the amount of water in the kayak increase or decreasing after 2 minutes? Increasing or decreasing? So the answer is increasing. Yeah, because the rate of in to the kayak is higher than the rate of build the rate to build the water out of the kayak. So it increased by how many liter per minute? It increased by how many liter per minute? 1.65 minus 1.09. That means it increased by 0.56 liter per minute. All right? Are you okay? So now, okay, now see, evaluate the following integral and interpret their meaning. So for part C, you evaluate this 0 to 3. You can straight away use your graphic calculator. R1t dt. Okay, can someone give me this answer? Okay, 3.25 liter. Okay, can someone interpret this? Mohammed, Amali, can you interpret this?
This would be the total amount of water leaked in, right?
Leak into the kayak. Yeah, correct. But if you say like that, I will not give you full mark. Do you know why?
After 3 minutes?
Yes, thank you. So this will be the total amount of water leak into the kayak after 3 minutes. Thank you. Or within 3 minutes. Also can. Okay. So that is called the interpretation. Okay, then what is the meaning of this? Okay, can someone give me the answer for this one? Okay, 5.27 liter. Good. So how am I going to interpret this? Okay, I'm going to ask someone to interpret. Cairo. Cairo, can you interpret that? Can you interpret this, please? Cairo, are you there? You see, I call, cannot answer me. Okay. Rachel Wen, are you there? Can you try to interpret this? Hey, exam, I sure ask you to interpret. If you don't want to try now, when are you going to try? Hello? C part 2 is 3.2. Are you sure? Part 1, 3.25. Okay, C part 1, 3.75. It's 3.75, not 3.25. Okay, you say so, 3.75. 3.72, okay. I told you already, I'm not an answer provider. The calculator can provide you with answer. Okay, so the value is wrong, but the interpretation is correct. So how about the interpretation for part 2? Ashley, you want to try?
Okay.
Mm.
The rate
Cannot be. If you integrate, you find the
at
area
which
definitely is total amount.
Evan
Total
the
amount.
total amount of water that Evan removed from the kayak
Mm.
from t equals to 2 to t equals to 5.
Yes, you are right. You see,
Okay.
you never try, never know. So always remember the area bounded by the rate of change of something will be the total amount of that something. That is how you start. Total amount of water, okay, removed by Evan from the out of the kayak from start from the time t equal to 2 to t equal to 5 seconds. Hello? Can or not? Okay, then how are we going to interpret number 3? Number 3, you got 0 to 8, R1, T. Take away R2, T. Someone have given me the answer very quick. Okay, so can you give me this amount first? You know how to use your graphic calculator to get the answer, correct? Yeah, 5.09 liter. Okay, so how are you going to interpret this? Still remember, when I say this, it's a minus or a plus, I can split, correct? I try to make you learn how to interpret. Okay. So, how am I going to put this in word? How am I going to put this in word? Can someone put this in word? Can someone put this, the black one, in word? Huh? Jasin.
Yes, Miss.
Do you want to try to put that in word? This one, the black one? Always start with total amount.
Total amount
Of, you look at what is
into
R1.
the kayak.
Yeah, total amount of water leak into the kayak. So some more. After, you have to tell the time. Hey, where are you? After what?
After 8 seconds.
8 minutes, not 8 seconds. It's minute. Okay, take away. Okay, can someone interpret the one in green? Okay, Yime, can you please interpret the one in green?
The amount of water removed
Okay.
from the kayak.
Yes, the total amount
Of water
of
removed
water removed
from the kayak after 8 minutes.
Correct, you are right. So if I put this in word, and I got 5.09 liter. So how do you interpret this 5.09 liter? Based on this one, you minus this. So how are you going to put this in word? Yes? Someone have told me that this is the total after 8 minutes. There is 5.09 liter in the kayak. Can I say like that? Can I say like that? No, why not? After 8 minutes, not meter, 8 minutes. After 8 minutes, I have this amount of water in the kayak. Why am I wrong? Can someone tell me? Because someone disagree with me. Then after 8 minutes, there is 5.09 liter of water in the kayak. Is it right or wrong? So it's a yes, right? So that is how you interpret. You get me? So we need you to know how to interpret things like that. So the important idea for integration is, okay, wait. This one. This is a very important idea. You get me? Can or not? Okay. So the rest of it, you just read the question accordingly. So on that note, I've completed chapter 5. Application. So important thing about chapter 5 is this one and the meaning of, other than this total amount, how to find the area bounded by a curve. Right? How to do an estimation. So for integration, what are the important things? You tell me. Can you tell me what are the important things for your SAT3?
Wait.
Hey, who is that? You are in the class, please don't play. Please don't play in the class. Okay, what are the important things for your SAT3? You don't talk, I don't talk. So SAT3. You must know how to integrate. You must know how to do integration. Second thing, you must know the meaning of area bounded, yes, by the rate of change curve. So that means this is under the application. That's all. You only have two concepts to know. So now I'm going to leave you with the integration. You go back and figure out how to integrate this. Do you think you know how to integrate this?
Not yet.
Not yet. Are you sure? Not yet. What is the first rule for integration? Do you think you can simplify this fraction? Why are you so sure that you say not yet? Just because here is a square. Can I simplify this? So integration and differentiation is the same thing. Simplify is the rule for math. Whenever an expression given to you is different from what you have been, what you have been shown, that doesn't mean you cannot integrate. You have to be creative and tell yourself that this can be simplified. So when you talk about simplification, there are many ways. So you have to be creative enough. So do you know how to integrate this? Hello?
ln x plus 3.
Yeah. So if whatever I give you is not of what the formula shown, definitely I won't give you something that I haven't teach you before. Am I right? So straight away you have to ask yourself this question. Can I simplify that? Are you clear? So that's why I say whatever is shown in chapter 4, please go and do it. There are some I didn't show you the answer. Okay, you try, you meet problem, you tell me, I show it to you. We still have 7 minutes. You want me to give you another one? Do you want me to give you another one?
I don't know.
Hey, who is that? Okay, I can give you another one. Do you think you are able to integrate this? Do you think you are able to integrate this? I can come out this in the exam. Can anyone think of a way to change this in the form that you are able to integrate? Okay, I give you some clue. I'm going to change this into a number plus a fraction. Okay, I'm going to change this. I'm asking myself, can I change it to a number plus a fraction? Here maybe can be minus, plus or minus can. Is it possible? Is it possible for me to do that? Like for example, I want a 1/2, correct? I can say this is 1 minus half. Can or not? If this is possible for number, it's also possible for algebraic. Do you think you can do that? So if I want to turn this, yeah. Okay, so now if I want to turn this to a number, so what must I have on top? So for example, I take this as number 1 or whatsoever. So that means now you have to, if you want to turn this to a number plus a fraction, what you need to do is you must know your denominator. Like for example, 1, correct? Can I write it as 2 minus 1/2? I try to create the denominator here. So isn't it 2/2 minus 1/2? I got 1 minus half. So the denominator play a very important role. So x minus 2 over x plus 5. So I create a denominator up here. But my numerator is x minus 2, not x plus 5. So what should I do here? I should take away how many so that I can have minus 2. Hello? Minus 7. Am I right? So x plus 5 minus 7, isn't it is the same as x minus 2? So why I choose plus 5 is because of the numerator. So now if you have a look at it, so this one I can write it as integral of 1 minus 7 over x plus 5. So this will be x minus 7 ln x plus 5 over 1. You see? So can I ask you all these are questions? The answer is a yes. So how are you going to modify it? That one, I leave it to you. All this technique of simplification, changing, is something that you have learned in year 11. It's very nice of me to explain all this over again to you. So, please take time to complete all the exercises in chapter 4 and chapter 5. If you don't do that, the same thing is going to happen again like your SAT2. Yeah? Okay, so that's all I can tell you. Okay, and please master how to use your calculator. So your SAT3 will be chapter 4 and chapter 5 without trigo. Okay? Okay, thank you, class.
Thank you, Miss.
Thank you.
Thank you, Miss.
Thank-
Miss.
So can we go over more questions on area of the two curves?
Yeah,
Like
why?
next lesson?
Why I need, which question you want me to go through?
Well, I
You
mean,
please.
questions in 5B.
Okay, you have question in 5B. Okay, during tomorrow lecture, can you please ask?
Yeah.
Okay, then I will go through with you. Yeah.